Hey, sorry I'm not there today. I hope you are having a wonderful day so far. Let's talk about what is in 3.3. All of this is from Algebra 2, so it should be familiar, but I absolutely realize that we may need to brush some dust off. So first, example 1, recognizing a polynomial. So when we look at which one of these might be polynomials, it's not going to be this one because a polynomial is smooth. It's very, very smooth. It doesn't have any corners. It's also not going to be this one because a polynomial is continuous. That means it has no gaps in it. So we know that we are going to have no gaps, no jumps. It's going to be continuous. You can draw it without lifting up your pencil. It's also going to be smooth with no corners. So that means that this is probably a polynomial and this is probably a polynomial. So, given a function, how do you find the x-intercepts? Well, the x-intercepts are where y equals 0. So, if it's not given in factored form, you want to factor it. And then you want to set each factor to 0 because you're using the zero factor property. And that's all. Let's do an example. So let's find the x-intercepts of this thing. So if I'm finding the x-intercepts of this thing, I know that my x-intercepts are where y equals 0. So I take my entire y, x squared minus 3x the fourth plus 2x squared, set it equal to 0. And then remember, when you're factoring, number 1, you always take out the GCF first. Then you look at the number of terms. If you have 2 terms, then you either do the difference of squares or the difference of cubes, those formulas. If you have 3 terms, you're going to use the AC method. And if you have 4 terms, you're going to do by grouping. You're going to factor by grouping. Hopefully all that rings a bell. If not, you need to look up difference of squares, difference of cubes, AC method, and factoring by grouping. And please make sure that you remind yourself of those. So if I factor this, well, then I get out an x squared, and I'm left with x the fourth minus 3x squared plus 2. Is that right? If I take out a second, I'm left with fourth squared, this, okay. And then I see that since this has 3 terms, I think the easiest way to do it would be using either the AC method or I'm just going to do it by inspection. I know that the first 2 terms of my binomial, when I break this up, must multiply together to get the first. And the last 2 terms of each binomial must multiply together to get the last of my trinomial. And so I'm pretty sure by inspection that this is going to be -2 here and -1 here. Just to make sure, you would multiply this out to make sure you get this, and you do. So now, why are we happy? Well, now we are going to use by the zero factor property. And what the zero factor property says, so the zero factor property, probably one of the most important ideas in all of high school mathematics, the zero factor property says that if a times b equals 0, then you know that either a is equal to 0 or b is equal to 0. And it goes both ways. So anytime you have 2 things that multiply together to get 0, one of them must have been 0. So that means here either this was 0, this was 0, or this is 0. So that means that x is either equal to plus or minus 1. Boop. Poop. X is equal to plus or minus the square root of 2, or x is equal to 0. Those would be all of your x-intercepts. So the x-intercepts are x is equal to 0, plus minus 1, and plus minus square root of 2. All right. You do not have to write out this every time or this, but I think everything else in here is a great way to write these answers. Okay, example number 3, find the x-intercepts, again, by factoring. Wait, let me see. So that's that. Okay, I already did that one. So look in here. Let's say it's already in factored form, then you're happy. So here, what's the y and the x-intercepts? Well, the x-intercepts are where y equals 0, and the y-intercepts are where x equals 0. So to find the x-intercepts, I set y equal to 0. So that means by the 0 factor property, either this first factor was equal to 0 or this second factor must have been equal to 0. So this is telling you that x is negative 3/2, and this is telling you that x is equal to 2, or your two x-intercepts. And then for your y-intercept, that's where x is equal to 0, you simply just plug in 0. So if I plug in 0 here and here, I get 0 minus 2 squared. Here I get 2 times 0 plus 3. So this gives me negative 2 squared, which is 4, and this gives me 3, so I get 12. So y equals 12 is our y-intercept. So our x-intercepts are x equals 2 and negative 3/2. Y-intercept is y is equal to 12. We answer the question. Let's look at example 5. It says, can you find the x-intercepts using a graph? Well, dude, I tried. What this one's really reminding you of is you try to factor that and you can't factor it by hand. One way is to graph it and find out where it crosses the x-axis. So here, just reading from the graph, x is equal to negative 3, negative 2, and 1 are our x-intercepts. Since the x-intercepts are where y equals 0. So y equals 0, boop, right here. So there's our 3 points. Now, what does it mean to be the multiplicity? Again, the multiplicity means if you have x minus c as a factor of your polynomial and it's raised to the n, then that is your multiplicity of the 0 x equals c. So here I have a 0, and what you're going to see is since it goes straight through like a line, then that's going to be a multiplicity of 1. Here, if we touch, that is going to be an even multiplicity, right? And here, since we cross, it's going to be an odd multiplicity. And we say we cross. So in general, you touch if you have an even multiplicity, and you cross if you have an odd multiplicity. Right? So if the factor associated with your 0 is raised to an odd number, then you'll cross. That will be your local behavior. And your local behavior at that 0 will be a touch if that 0 has an even multiplicity. All right, so let's do some examples. So how are we going to use this? Let's identify some zeros and their multiplicity. So here it should be pretty clear that at x equals negative 3, we have a 0, right? And it's pretty clear that here it touches. So that means it's going to be an even multiplicity, right? At x is equal to negative 1, we cross, so that's going to be an odd multiplicity. And then here at x is equal to 4, we also cross, and so that's going to be an odd multiplicity. Right? Okay. So I think we can actually say even more. So for each of these zeros, boop, boop, right here, for each of these zeros, since x minus 3 is a 0, that means that x plus 3 is a factor of my polynomial. Since x equals -1 is a 0, then that means that x plus 1 is a factor of my polynomial. And then since x equals 4 is a 0, that means that x minus 4 must have been a factor of my polynomial. So that's how these zeros and the factors relate. In general, if x equals c is a 0, then x minus c is a factor. Okay. So, bloop, 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 bloop. And so what does that mean? So that means that if I come in here, now I need this function is degree 6. So that means that all the multiplicities must add to 6. Well, here, if I look at this, that is, okay, so let's start again. So, if I look here, since this 0 is an even multiplicity, I'm going to say that we probably have x plus 3 squared, because it really, locally, it looks like it wants to be a square. Here, since it looks like a line, I'm going to say that x plus 1 is just to the first. So now notice, so far, if all my polynomial was x plus 3 squared times x plus 1 to the first, I would have a polynomial of only degree 3. Because 2 plus 1, when you multiply it out, will give me an x to the third plus a bunch of crap. Well, now, if I look here, so that means my last thing must be cubed. So my last factor, since x equals 4 is a 0, then x minus 4 is a factor. It means that I must have x minus 4 raised to a factor of 3. When I look locally, it looks like a cubic. So that means that x minus 4 raised to the cubed to the third makes complete sense. So this would be a polynomial that looks like that graph, right? So use the graph of the function of degree to identify the zeros and their possible multiplicities. So this is one possible version of what that function might look like. I think we can tell because we have this here, I could probably do an even better job of figuring out what this is, and we'll talk about that soon. So notice I could put a constant out front and use this piece of information to find out what that constant out front would be. Okay. So I'm going to talk more in just a little bit, but with that, I'm going to stop now.